In this video, I'm discussing first 15 questions of Grand Test 8 related to physics. Here, n identical cells, each of if two cells are connected in series, net EMF is 2E. Three are connected 3E. Like this, n cells are connected, so then effective EMF will be NE. But here, what he did is, out of n cells, he connected one cell with reverse polarity. So here effect of this is nullified by this. That means there are only finally n minus 2 cells are there with EMF E, and all cells have internal resistance since they are connected in series. Each resistance of each wire is R. They are connected in series. Effective resistance will be NR. So here the current through the closed circuit is nothing but n minus 2 E by NR. Now question here is potential difference across each cell. So here each cell has an internal resistance R. Potential difference between these two means VA, actually current flows like this, irrespective of in which direction it flows. So path is chosen like this, positive to higher to lower, minus E. Here you have to write plus IR. So against to the direction of flow of current by using Kirchhoff's second law. So VA minus VB will be E minus IR, which is E minus I. We already got it as N minus 2E by NR. Here I is N minus 2E by NR into R, get cancelled. That is E minus NE minus NE plus 2E by N. So potential difference across each cell, first option is correct. Here, cell of internal resistance drives a current through an external resistance. So effective resistance is R plus R since they are connected in series. EMF of a cell is E by Ohm's law. The current through the circuit is this. So power delivered by cell is equal to I square R. So that is equal to E by R plus R whole square into R. It is a function of internal resistance of a battery is fixed. It depends upon external resistance. For what external resistance power delivered is maximum. So for maximum dP by dr is 0. So E square is constant. So R plus R whole square into R minus R into R plus derivative of this 2 times R plus R by R plus R whole power 4 is 0. Once you simplify it, R into R plus R, if you take common, R plus R minus 2R will be 0. That is capital R is small r. So when external resistance is same as internal resistance, power delivered by battery will be more. Here on an inclined plane, it has a linear acceleration. So linear acceleration will be acceleration of the center of mass So for a body which is rolling on a inclined plane, you can get this derivation by using and round shaped body is rolling. mgh is equal to, it has translational plus rotational kinetic energy half into mv square into 1 plus k square by, from this you get velocity since center of mass is moving in a straight line. V is equal to u plus, right? This formula, if you apply, you get acceleration, right? Now here, uh, he told this is equal to g by root 3. Theta is given as 60 degrees. G sine 60 root 3 by 2 into 1 plus k square by r square, which is g by root 3. So 3 is equal to 2 times 1 plus k square by r square. Here is 1 is, so k square by r square is half. So now this is possible, I think, for disk mr square by 2 is mk square. So k square by r square we got half, that is suitable for disk. A small body of mass m slides down from the top of a hemisphere of radius r. The surface of the block and hemisphere are frictionless. The height at which the body lose contact. When it is in contact with the surface, when it comes to a height h, the forces acting on it, normal reaction perpendicular to the surface. At this point, you draw a perpendicular that passes through the center. So weight act downwards. So here its component mg cos theta, so will act along the normal. So in non-inertial frame, actually it has moving in a circular path, centripetal acceleration, centripetal forces towards this. So now you solve the problem with respect to non-inertial frame. Pseudo force acts on this in opposite direction to force, centripetal force. That is n plus mv square by r is equal to mg cos theta. So when it loses contact, body loses contact, normal reaction is 0. mv square by r is mg cos theta. So v square by r is g cos theta. So here it is h. So cos theta from the diagram, it is h by r. So he is asking the height at which body loses the contact. So this is nothing but gh by r get cancelled. V square is equal to gh. So height will be v square by g. So that height we should express in terms of radius. So at this point, when object is here, with respect to this as a referential line, it has potential energy. When it comes to this point P, it has potential energy plus kinetic energy of mv square. M everywhere it get cancelled out. V square by 2 is g times r minus h. V square is 2g into r minus h. So in place of H is equal V square is 2G into R minus H by G, 2R minus 2H. So here it is 3H is equal to 2R. H will be 2R by 3. So second option is correct. Frequency. The amplitude of oscillation gradually increased. So then when it is at highest position, uh, here is an object. In fact, this is the coin which is placed on a platform. At highest position, normal reaction, that's a force exerted by the platform on the coin. So its weight. At extreme position, acceleration will be towards the center. That is mg minus n is equal to ma. N is m times g minus c. When it is at lowest position, here is normal reaction, here is mg. Acceleration will be towards the center. Here n minus mg is equal to ma. Here n is m times g plus a. Here normal reaction cannot be zero. So at highest point, there is a possibility that normal reaction will be zero. When as long as coin is in contact with the platform, there will be normal reaction. Coil will leave contact. Coin leave contact when normal reaction is zero. That is nothing but m into g minus a is zero. So that since it executes SHM, acceleration is nothing but omega square x. So g equal to a, which is omega square x. One is it loses contact. At lowest position is wrong, main position is wrong, and amplitude. So that is omega square a is equal to g. That means this x is displacement. At a maximum value of x, it loses contact. So amplitude here is g by omega square. Here it is input signal. Once it is sent through NAND gate, here it is NAND means not negation of AND gate. That is here. So at this point, it is A dot B bar. Again, through this signal A is sent. Through this, again here, NAND gate. NAND gate means A dot B bar whole conjugate. Here, through this input signal is B. Through this, again, NAND gate input signal. Here, when it is come out of this NAND gate, output signal is B dot A dot B bar bar. Now here input signals are, one input signal is, this is nothing but A bar dot plus A dot B. Here it is nothing but B bar plus A dot B bar bar, which is simple. 。 . 。 。 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . Now, y will be, again, these two signals are sent along this NAND gate, a bar plus a dot b bar plus a dot b, negation of this. So finally, that is a bar uh, plus ab bar, so it becomes plus b bar plus a dot b whole bar. Is a negation dot. We will have here a dot b bar plus b. Here it is a dot b bar. It is a dot a bar plus b bar, b plus a bar plus b bar. So this is a dot a bar, a dot b bar, b dot a bar plus b dot b bar. A dot a bar is 0, b dot b bar 0. Finally, you'll have b dot, right? So it is b dot a bar, a dot b bar. So suppose you take first option, 0 0 complement, 0 0 complement, you get 0. Second option, 0 1 complement, 1 0 complement, 1 complement is 0 0 complement is this, you get 1. So like that, remaining two options you check. So here we have to check because first and third option, first two are coinciding. Let us take 1 0 as an input signal. This is 1 plus 0, which is 1. So 100% first option is correct. To have a maximum percentage error, x is AB by C cube, log x will be log AB minus log C cube, log AB minus 3 log C. So error in x will be delta x by x, which is here log A plus log B minus 3 logs. Delta A by A plus or minus delta B by B minus or plus. So for maximum error, percentage error, it is delta A by A into 100 plus delta B by B into 100 plus 3 delta C by C into 100. He given 112%, 116, that is 8. Here he given Px graph, power and displacement graph. So area under Px graph, what it gives, integral P dx, which is nothing but a trapezium. So here it is 0, 10 by 2, 5. A is this, B is this, that is 2 plus 4, you'll have 30. Here, if you consider this as x-axis, y-axis, on y-axis, x is 0, 2. Here it is 10, comma 4. So power, actual equation, y minus y1 is m into x minus x1. Your y in the sense power, y1, I will take any coordinate. M here is along x-axis x only, x1 is 0. So that is T is equal to 2 plus x by 5. Or this is integral P dx. So x from 0 to 10 is same as what he is asking here. Its power varies. Initial velocity is at 1 meter per second. Velocity at 10 he is asking. So when x is 10, what will be the velocity means? Initially, when x is 0, its velocity is 1 at 10 centimeters. What is its velocity? Power we can write Fv into dx. So this is by default you assume it as constant force. 1 to V. Fv you can write m av dx. This we can write it as ma 1 to V. Acceleration is dv by dt into V dx. So he is given mass 10 by 7 kg. dv by dx into dx by dt into V dx, which is 10 by 7, 1 to V. dx by dt is velocity, that is V square dv it becomes. V cube by 3 between 1 and V cube minus 1 by 3, which is 30. So V cube minus 1 is, so V cube is 64, V is 4 meter per second. Suppose you don't have trapezium idea, then you can integrate by substituting here. You get answer as 30. Here it is motional EMF. EMF induced is V cross B dot dl. Here it is V cross B. If you consider here B, he given it as V cross I cross J, which is K. But dl is in XY plane. So V cross B dot XY plane means any vector we can write. So V naught B naught K times A plus B. So K dot I 0, K dot J also 0. So EMF is not induced, right, across the PQ. And here, Biot-Savart's law. magnetic field due to the wire which carrying current at a I at a point P from it, magnetic field due to small element dB is equal to dl cross r bar mu naught by 4 pi r cube. Suppose here, if it is a semi-infinite wire which carries a current I, semi-infinite, so magnetic field at point O about if a wire carrying a current I, which is at a distance, this what distance? A. So we know the formula magnetic field due to wire carrying semi-infinite wire carrying a current I is B equal to mu naught I by 4 pi r. That is mu naught I by 4 pi. But here, what will be the direction means this is r bar. Current element is this. So dl cross r bar means magnetic field will be inverse. And due to BC part, so here again semi-infinite wire, magnetic field at same distance 4 pi. The direction, this is r bar, it is dl bar, dl to r clockwise direction. Clockwise direction means again here inwards. So the net magnetic field will be mu naught I by 4 pi, which is 2 mu naught I by 4 pi a. That is mu naught I by 2. But due to this part, here wire is, here also wire is there. So with respect to this, R bar is this. So here it is, current is flowing like this. DL, between DL and R angle is 180 degrees. So in that case, in fact, we have a formula mu naught by 4 pi DL R sine theta by R cube. Theta is 180. Magnetic field will be 0 because of this and this. So the net magnetic field is only this. So here, two coil here he given, one is self-inductance, other is mutual inductance. So if two coils of inductance L1 and L2 are linked in such a way, this is L1, here you have these are two different coils. When current I flows through this, so in the neighboring coil, right, magnetic field lines will be there. some flux. If you change the current here, there is a change in magnetic flux. So because of current in one, so there will be EMF induced in the second. That EMF induced in the second is minus m di1 by dt. Similarly, when current is flowing in the second coil, because of that magnetic field lines, here EMF is induced, that is E1, because of the current in second coil, m di2 by dt. So now here we got ms minus E2 di by dt and another ms minus E1 by E1 by di2 by dt. So here once current within the coil, current keep on changing, flux keep on changes. So EMF induced in the coil which opposes that E1 will be minus L di by di1 by dt. Similarly, I1, I2 current flows through it. EMF induced in the same coil L2 di by dt. Now we have to establish a relation between L1 and L1, L2 and M. Here I will take here M1 and M2 are same. I will write M1, M2, which is same. That is minus E2 di1 by dt into minus E1 by di2 by dt. So here E1 by d, this rearrange it, E2 by di2 dt into E1 by di1 by dt, which is L1 into L2. So that is what. So here in this problem, he given graph between load and extension. First thing, for 4 wires of same material. Same material means Young's modulus is same. Same length. And different cross-sectional areas. So question is, which line represent thickest wire? Which has more radius? That is thickest wire. Which has lesser radius? That is thinnest wire. Young's modulus, stress by strain. So force per unit area, change in length by unit. Right? So here we want elongation, which is this load, this F by delta L is equal to YA by L. So for all wires, Y constant, L constant. F by delta is proportional to cross-sectional area. Per cylinder, wire is cylindrical shape, cross-section is circle, the bias. That means here, suppose for wire D, tan theta will be F by delta L. Along y-axis force, along x-axis elongation. So in this way, here F by delta L is k times pi r square, which has more F by delta L value, that wire radius will be more. If you consider in this graph, so OA makes largest angle with x-axis. So that means tan theta is more, which means F by AL is more, which means k times pi r square is more, which means F by delta L is more, sorry. Tan theta is more, F by delta is more, which implies for k times pi r square is more, which implies r square is more, which implies wire OA is thickest. Here, angle has no dimensions. Here, then something is missing here. I think d by d represents. Dx has no dimension. X is measured in length. B dimensional formula is the L inverse. Similarly, dt has no dimensions. So that is dt. I can write t inverse into t. Then in such case, no dimension. So let us write d by b. So that is T inverse by L inverse, LT inverse, which is dimensional formula for velocity. The second option is correct. Here Einstein's photoelectric equation. So E is equal to work function plus kinetic energy maximum. Here metal surface is illuminated with a light. That incident energy is Hc given 1240 electron volt nanometers, 400 nanometers. So it is 3.1 electron volts. So kinetic energy maximum he given. This is 3.1. Kinetic energy is 1.68. Work function is minus 1.68. So here it is 1.42 electron volts. And here minus q plus q plus q plus q. You have to find potential at the center of a square. Let us say midpoint of diagonals are all at equal distance. Potential at P is potential at P due to charge present at A, potential at B due to charge present, potential at P due to charge present at C, potential at P due to charge present at C, D. It is nothing but KQ by R minus KQ by R. At C, it is K minus Q by R. At Q, it is KQ by R. So potential at center is 0. Regarding electric field at this point, so electric field means test charge is positive, they repel. So net force acting on it will move like this because of negative charge. This unit positive charge will move in this direction. So because of Q, this Q, this charge moves in this, because of negative charge it moves in. So net force will be along the bisector of BOC. When charges are not replaced, so net force will be along angle BOC. That is bisector of angle BOC. Right? That is net electric field. Suppose here, if charges are numerically same, charges are replaced, interchanged, then here a unit positive charge. So because of this positive charge, electric field will be like this. Because of negative, it moves in the same direction. Because of minus Q, this positive charge will attract. Because of this, it repulsion will be occur. So here it is, charges are interchanged. Then net electric field magnitude is same, but direction will be along bisector of angle AOB. So V remains unchanged. Electric field changes.